Hi, everybody, and welcome back to video number 6 in Chapter 5. When we left off, we were looking at Norm and Jackie Reamer's calculating an ordinary annuity for a college funds. They've saved $36,000 to finance their daughter Donna's college education. They deposited the money in their local bank where it's earning a 4% interest compounded semi-annually. What equal amounts can their daughter withdraw at the end of every 6 months during her 4 college years without exhausting the fund? Okay, interesting problem. So what we're going to do is, first of all, we'll look at the present value of an ordinary annuity. And we check that out, and we look that up for end of 6 months for college years. So that's going to be 2%, 4% divided by 2, and we'll double the 4 to 8 periods. So if I look that up, we've got 2%, 8 periods, and that's going to come right off of table 5.4. And we just simply divide that into 36,000, and away we go with $4,914.35. All right, here, the Healthy Hearth Company, a maker of gluten-free breads and bagels, hopes to increase its market share in the upper Midwest. To do so, Healthy Heart has decided to locate a new factory in Fargo, North Dakota. The company will either buy or lease a site depending on which is most advantageous. The site location committee has narrowed down the available sites to the following 3 similar alternatives that will meet its needs. Here, under option 1, building A, we purchase it for $1.3 million cash. This building is larger than needed. However, the excess space can be sublet for 25 years at a net annual rental of $14,000. Rental payments will be received at the end of each year. Healthy Heart is happy to be a landlord. Okay, option 2, building B, lease for 25 years with annual lease payments of $140,000 being made at the beginning of the year. And then option 3, building C, purchase for a cash price of $1.2 million, and its useful life is 25 years. Okay, so explain which alternative you would recommend, assuming a 12% cost of funds. Very realistic scenario here. Okay, so for building A in option 1, we're going to take this rent of $14,000 and multiply it through times 7.84314. And that's going to be right off of the 12%, 25 periods. So let's see if that lines up. $7.843, yes, it does. So we would get that right off of the table 5.4. And so the present value of all that is going to be $109,804. So now we're going to take the cash purchase price that's already at present value and back out the amount we make from rental income in present value terms. And that says our net present value cost is 1.90196. Okay, so for building in option 2 here, we just simply had rent for 25 periods. We'll use that 25 periods at 12 an annuity due, because let's go back here. They made that at the beginning of the year. So we have to go into the table 5.5 and we go for 25 years and 12%, and that's 8.78432 from table 5.5. Multiply that through times 140,000 and we get 1.229805. That's the present value. So that costs a little bit more than option alpha. All right, in option 3 here, buildings Charlie, present value of 1.2 million today. That's already, we don't need to do anything to that. That's already at present value. So we would recommend doing present value or building, or the first alternative here, as its net cost is the smallest. Great illustration there. This comes up all the time in the real business world. Okay. Deferred annuities, bonds, and expected cash flows. We had a little bit of this in 1A and 101, and unless you had me for that class, you probably didn't get a whole lot of background on doing some of this. But the rents begin after a specific number of periods. That's a deferral. Future value of the deferred annuity. The calculation is the same as the future value of an annuity not deferred. So the present value of a deferred annuity then must recognize the interest that accrues during the deferral period. So here's the present value, here's the deferral period in here, and then away we go with our money. So let's do an example. Sutton Corporation plans to purchase a land site in 6 years for the construction of its new corporate headquarters. Because of cash flow problems, Sutton budgets deposits of $80,000 on which it expects to earn 5% annually. Only at the end of the 4th, 5th, and 6th period, however. What future value will Sutton have accumulated at the end of the 6th year? So this is graphically displayed here very nicely, and we want to know what that present value is. So we're going to determine the value of that. We're going to go into 5% annually, and we're going to have 3 years here, okay? And if I do that, I'm going to take this 80,000. Let's go find that real quickly. The future value of an ordinary annuity, that's going to be back on future value of an ordinary annuity. And that's going to be back on table 5.3. We're going to go look that up for 3 periods at 5%. So here's 5%. And as you see on table 5.3, that factor of 3.15250. And so we multiply that through and we get $252,200. Okay. Okay. Present value of a deferred annuity then, computing the present value of a deferred annuity must recognize the interest that accrues on the original investment during the deferred period. To compute the present value of a deferred annuity, okay, we got 3 steps here. We're going to compute the present value of an ordinary annuity as if the rents had occurred for the entire period. Then we're going to subtract the present value of the rents that were not received during the deferral period. And the difference is the present value of the rents actually received subsequent to the deferral period. Okay, if you follow all that, let's look at an example. Here, Bob Boyd has developed and copyrighted tutorial software for students in advanced accounting. He agrees to sell the copyright to Campus Learning Systems for 6 annual payments of $5,000 each. The payment will begin 5 years from today. Given an annual interest rate of 8%, what is the present value of those 6 payments? Okay, we got to do the 3 steps. So first, this situation is an ordinary annuity of 6 payments deferred 4 periods. So 2 options are available to solve that problem. Okay, so we have the 4 periods here and 6 periods there. Okay, the first option is to use table 5.4 using the method discussed. So here we have $5,000. The present value of the ordinary annuity for a total of 10 periods at 8%. So if I go into the 5.4 here, 10 periods at 8%. I'll find it in a second here. That's going to be, okay, so we come up with 6.71008. So that's going to be the present value of an ordinary unit for 6 plus the number of deferred periods at 8%. So I'm going to go to there. Okay, so we get our factor here. Now we're going to subtract out the present value here of 4 deferral periods at 8%. I'll go into 8% here, find 4 deferral periods. I get 3.31213. I got that one. And for 6 periods, then that would be the other one at 8%. Okay, so that's the present value of an ordinary annuity. Okay, and so we're going to take this and subtract it from this 6.71008, and we get 3.39795 multiplied by 5,000. We get the present value of 6 rents, $5,000, 4 periods. Okay, the subtraction of present value, then, of the annuity of 1 for the deferred period eliminates the non-existent rents during the deferral period, and it converts the present value of an ordinary annuity of $1 for 10 periods to the present value of 6 rents of $1 deferred 4 periods. Okay. Now, Boyd can use tables 5.2 and 5.4 to compute the present value of 6 rents. He can first discount the annuity's 6 periods, right? And then because the annuity is deferred 4 periods, he must treat the present value of the annuity as a future amount to be discounted another 4 periods. To me, this is easier to understand. So what he's going to do here is he's going to go grab the present value of an ordinary annuity here, 5,000, 4.6228, and then that's going to be 6 periods at 8%. 6 periods at 8%. Yep, and that's exactly where that comes from, table 5.4. And that gives him 23.14. Then he's going to take that present value of this single sum and discount it back to the present. And we go grab that. I think that's table 5.1. I'll check that